Doing fine. We have a busy day today. We've got as our guest of honor, Bill Nye, the psyops guy. But before we can get to him, we need to look at some of the fan mail that I got. I'm going to answer some of these comments, some of the questions, some of the issues that these people bring up. Okay. And one of the first ones is this one. He says the electron is a concept. Not the shell of the concept. A serious physics scientist must know that the electron thing is a mathematical abstraction. We've never seen electrons. We've never touched electrons. We never measure electrons. Electrons is what they named the response appearing on instruments. Okay? There is nothing showing its shape, motion, or existence. It's a guess. It ignores the field, the worst guess I've ever seen, because it ignores the field around the point, which is creating the so-called particle. How did you not know this, Bill? Okay, so what do we respond? Well, here's my reply to that. Okay, let's go point by point. Let's see how many errors this person made. Okay, the first one, the electron, I like the fact that he says the electron is a thing, but then he says it's a concept. It's a thing that's a concept. Well, you know, either it has shape or it doesn't have shape. Either God has shape or God does not have shape. And he can't have both. And the same thing for the electron. Either the electron has shape or the electron does not have shape. There's no two ways about it. Every word in the dictionary either falls under one category or the other. There is no third category for the purposes of physics. Either it's an object and it has shape, or it's a concept and it doesn't. Period. We're done. Now we can use these words consistently. And, you know, nothing, which is the main concept, otherwise known as space, otherwise known as vacuum, that's a concept. There is no physical object called space. And as far as seeing electrons, well, we don't see, touch, or measure in science, so it's irrelevant. Okay, we don't use these words like, oh, I've used my senses. No, the only sense is the common sense, which is the least common of all senses. Okay, yeah, we detect electrons indirectly. Okay, so there's an indirect detection of electrons, and that's fine. We don't have to see or touch them. What we have to figure out is what invisible entity is in there, you know, and with whatever we've got in there, we have to explain Mother Nature's phenomena, you know, what she does. We don't show shape, okay, so showing shape and showing existence, we don't point to those. What we do is define what existence is. And as far as shape, we point to the object. We're done. So we don't show in the sense of proving, which is how he uses it here. He's talking about proving shape, okay, like saying we've never seen the shape. That's a question of proof, and that's a question of belief. We're not going to see the shape of things which are invisible and intangible, such as electrons, light, gravity, and all those other mediators, magnetism, electricity. So we will not see that. We will not show, you know, like I showed the other day between two plates, a cathode and an anode. You're never going to be able to point your finger and say, oh, look, there are all these electron balls going from one place to the other. No such monster. You have to make an assumption. And he calls that a guess. But no, it's called an assumption, a hypothesis, okay? Is it a guess? Yeah, you could say it's a guess. It doesn't matter. As long as you use this assumption to explain something, then you're okay. You're doing science, okay? So yeah, we do a guess. Now, he says that's the worst guess that he's ever seen. Well, that's his opinion, okay? I kind of agree with him as far as the electron being a little particle, but again, that's my opinion. Okay, Point, we don't use it. Field, we don't use it. These are unscientific terms. You cannot use these two words, okay? Field is a concept, and point is a concept also. The word point means location. The word field, who knows what that means? We don't know anymore. It used to mean, you know, the lines of force around a magnet, but that's been expanded to electric field and gravitational field. And no, we don't create anything in science. So this thing which he says, field around the point which is creating the particle. Okay, then the particle has to be a real particle. It can't be just a nonsense point particle, a concept. It's got to be a particle. It's got to be a ball or a cube or a triangle. Yeah, it could be a triangle. It could be 2D for all we care. But that's up to the presenter to make his case, right, to defend his proposal. And how did you not know this, Bill? Well, knowledge is not a part of science. And this poor fella is still living in religion. He thinks he's doing science, talks about knowledge. The word knowledge belongs exclusively to religion. Once you know, means you got a religion. Okay? It means you made up your mind. Okay, and that's you, because the other guy has a different knowledge. You know, one guy knows that God exists, the other one knows that God does not exist. So they both know. And they both provide evidence and proof and experiments and whatever. Okay, another comment. Black holes are just nothing but compacted knots of plasma, which could form a disk, swirl, or a spiral where the energy is very dense. It is called a plasmoid. We refer to all the people in the electric universe as plasmoids. We call them plasmoids, okay? But he says this thing that he's describing there is a plasmoid. Okay, black holes ought to be plasmoid rings, not bottomless pits inspired by Einsteinian physics. Reasonable evidence that black holes are plasmoids include the shape of galaxies, straight-up jets, X-rays and gamma rays emitted, strong magnetic field, filamentous dust of charged ions. Okay, so what do we have to say about this? Let's see if we get it here. This is the issue. Plasma is a concept. There's no physical object called plasma. And that takes a while for someone from the electric universe, especially, you know, to understand. In fact, I don't think anyone from the establishment understands that. Plasma is a concept. There's no physical standalone object, static concept, a static object called plasma. Okay, and I know this offends a lot of people because they say, what do you mean? I was once banned because I said that plasma is not an object. The electric universe, they kicked me out of their site. Okay. Here's plasma. Okay, here's a simulation of what the problem is. Here we have a kangaroo on the left hand side. You can see it's not moving. That's how you present an object in physics. You point to it and name it. Say kangaroo. Now the ET understands your language. He understands what a kangaroo is because you're pointing to it. And I just have a two-dimensional picture here. He could, you know, you could just as well point to a 3D or a real live kangaroo and say that's a kangaroo. Now what's on the right-hand side is a jumping kangaroo. And a jumping kangaroo is a concept. It's not an object. Okay? The object is the kangaroo. What he's doing is a concept called jumping. Okay? So we have jumping kangaroo is not a physical standalone static object. Okay? And I can't put that kangaroo in the middle of space, it being the only object in the universe, point to it and say that's a kangaroo. Because that kangaroo is not standing still. What we're watching is a movie. And a movie, any object that is in motion, is a concept. It's a dynamic concept. A running boy, a flying eagle, a swimming bird, swimming fish, all those are concepts. There's no physical object called swimming bird, or I said bird again, swimming fish or flying bird, okay? no physical standalone object. It's got to be the only object in the universe. It's got to be standalone. It's got to have a backdrop of space, which provides the contour, and you point to it and name it. That's the only way to present an object in physics, and plasma does not qualify under those criteria. Okay, and here we see again what the difference is in regards to plasma. The quantum atom is what, at least, the one we have from the days of Niels Bohr and Ernst Rutherford, is that thing that you see there. It's a proton, and next to it you see an electron. That's the static notion of what quantum mechanics says is an atom, a hydrogen atom. So that's the way you would point to it and say, this is an atom, which is two objects. Again, we got a problem with that, but that's aside. Here on the right hand side you see the jumping kangaroo, which is what we see in the plasma. Plasma is ionized gas. You have to ionize. You got to do something to the atoms in order to create plasma. So plasma is not a standalone object. It has to be ionized. Okay, the atom has to lose its electron according to quantum mechanics. We have a different interpretation of what ionization is under the rope model, but essentially there you see why plasma is not a physical object. You can't point to plasma because you're not pointing to a single frame in the movie, you're pointing to a movie. And a movie you can't point to, you got to scan your finger. And we don't want you scanning your finger. You got to point and keep that finger steady. And you can't do that with plasma because it's moving all around. And people don't understand that. And that's why we need to define what an object is for the purposes of physics so that people do not confuse movies with pictures. They're confusing film strips with standalone objects. And they introduced them as, one famous one is field, okay, energy, another one. They introduce these words and they say, oh, energy. And the energy does this, it converts to mass. The issue here is there is no physical object, standalone object, non-moving object called energy that you can point to. There is no physical object called time, there is no physical object called mass, and there is no physical object called field. You cannot use those concepts, those dynamic concepts, in lieu of or as physical objects in physics. And that's 99% of what the problem is with mathematical physics. They're using all these dynamic concepts, and they're treating them as physical objects. And the people like the Electric Universe, the Flat Earthers, the people at the John Chappell, or Chapel as I call them, Society, all these people do the same thing. They're moving concepts around. They don't even realize it. They say, well, you got to explain it with concepts. No. We don't explain it with concepts. We got to show a movie, and there better be objects on the screen. I better see shapes. Then I can understand the mechanism, which is what we're trying to find out. We're trying to figure out how Mother Nature does her daily work. It's got to be done with objects. If you don't put an object there during gravity, if you don't put an object there during ionization, plasma, or whatever, what you're doing is, in effect, introducing spirits in that same space. Okay? Okay, so here's our atom, just in case, okay? You see the bottom left there, there's the atom, and upper, in the middle there, you see how it's constructed, okay? So that's our atom, so we do point to our atom, and you can see the electron shell, which is that red line, curved line going around. That is a physical object. Here it's in 2D. We have a 3D model as well. Again, you can think of it as a ball of yarn, okay? So, here, in fact, looks more or less like this, okay? Ball of yarn, that's what it is. That's how you would see an electron. And a ball of yarn is a physical object, yes. It's got shape. I know this is news to some people, but that's how simple it is. Physical object you can point to if it has shape. And we point to an electron shell, which is more like, again, like the surface. This is the way I visualize it, as the surface of a ball of yarn, because you got to think of all these what we call magnetic threads, just constructing from every atom in the universe, right? Constructing the electron shell all around, okay? So that's our model of the atom. On the other hand, this atom that let's see if we can put this back up here. This atom that quantum has on the left-hand side, you can't even explain why the electron is faithful to the proton. Why doesn't the electron spontaneously fly away? And yeah, they always show it going around. They show, when they show a static image of the atom, they show this ring. And this ring represents the orbital. What is an orbital? It's the orbit of the electron bead around the proton, right? And they say, well, that's the orbital. They turn the orbit, an itinerary, into an orbital. And then they made a 3D saying, well, the electron goes in all these directions, so it's going around in every direction, forming this ball, okay? And so the question is that a movie or is that a photograph? And obviously that's a movie, what they're pointing to. And so the quantum atom is a movie. That's why they don't understand. That's why they can't point to it. That's why they say, well, you got to go to college to get a master's degree to understand what an electron is. Well, I don't need to go to college to know what a dog is or a tree or a rock. I just point to it. Please point to the electron. To the electron orbital or whatever they're going to point to. Well, they point to a bead. They show it going around, describing or constructing a shell, which they call the orbital, okay, the orbital, and then they say that's the atom. Now that's a movie of an electron moving around a proton. That's not an atom, and that's the problem. Anyone who wants to talk about physics and they're going to use the atom, well, they have to start by drawing their atom. Okay, got another comment here. Is this the one? Yeah. And this fellow accuses me. He says, I don't like Tyson, but I don't support attacking someone for his beliefs. Oh my God. Okay, here's my answer to this. Here we have, oh no, wrong guy. I'll get him in a minute here. Got the wrong one. Here we have Mr. John Bias. I presented him in the past. And he created the crackpot index, which is lodged at the University of California at Riverside, which is a state-funded institution. And in it, he's got the crackpot index with which he belittles anyone who, he says 10 points for each claim that quantum mechanics is fundamentally misguided. He says exactly the same thing about general relativity. And then he says 10 points for arguing that while a current well-established theory predicts phenomena correctly, it doesn't explain why they occur or fails to provide a mechanism. Well, that's interesting because that's exactly what we do here. So Mr. Bias disagrees with our way of doing science. He believes that you're not supposed to answer why questions. By why, I don't mean purpose. I mean causes, mechanisms. He's saying that science doesn't do that, physics doesn't do that because he's a mathematical physicist. And he says that you can't challenge quantum or relativity because if you say that it's fundamentally misguided, well then you're a crackpot, you're a crank. And so these people belittle and they use the crackpot index against anyone who disagrees with them. But this fellow wants me to not badmouth the celebrities. It turns out these celebrities are all in the same boat. They all essentially vouch for general relativity and quantum mechanics, string theory as well, right? And if you attack any of those, you're a crank. You're automatically a crank. You're not allowed to publish. They censor you. They belittle you. They make fun of you. They ridicule you, your theories. That's okay. But I can't go in there and criticize these guys and treat them with the respect that they deserve. Well, I think we don't have a level playing field. That's what I think, okay? And so Yeah, I can sleep well at nights, believe me. I don't care about these guys because what they do is they propagate ignorance. And that's how I see them. Okay. Okay. Oh, by the way, here we had John Rennie, another fella, okay, from the same guild, okay, mathematical physics. He runs the Stack Exchange. He's got all these medals on his chest. Editor-in-chief of Scientific American, Public Library of Science, la la la. Deputy editor of Quantum Magazine. In other words, he's a censor. Okay, that's what he does. He censors. That's his job. And he also ridicules people. He says the first job of any scientific fraud is to persuade the public that science is itself unscientific, which is exactly what I say. The science we have today is unscientific. Why? Because it does not explain causes and mechanisms, which is what Bias objected to, first of all. And second, because all their physical interpretations of people like John Rennie and John Bias and all these other bozos like Brian Greene and Michio Kaku and Tyson and the guy we're going to deal with today, Bill Nye, all these people do the same thing. They have irrational explanations, irrational physical interpretations, which they sell to the public as done deals, as proven truth. And you're not allowed to criticize that because these people control who publishes and who doesn't. That's so for those people who accuse me of being naughty with all these celebrities, well, all I can tell them is go find yourself, do some research and find out for yourself. You know, if you can publish something against general relativity, quantum mechanics, or string theory, I challenge you. And before you accuse me, go to the University of Riverside, and tell the president of that college why he can't get that crackpot index out of there. I mean, it's used to belittle anyone who opposes quantum and general relativity. You would think that's a misuse of state funds. So start there. Don't start with me, okay? If you got a problem with the way I treat these celebrities, okay? And it just means that this fellow is not in touch with what's going on in the scientific world. He just blobs, says, oh yeah, you're mistreating all these great celebrities. You know, I mean, who cares about them? They're making a lot of money selling garbage to the public. I think the way I look at it, they commit crime against humanity for what they're doing. I would put them in prison. That's what I would do. So I'm being too nice to them. Okay, fellow that we're going to deal with today. This fellow, I used to watch him when I was a kid in the 60s, and he comes way before me. He comes from the 50s. There was a program when I was a kid called Watch Mr. Wizard. Okay. And I saw him in the 60s. Again, he was there already since the 50s. And he would do some little magic tricks with science there, you know, some science experiments, some flashy experiments. And I used to watch him several times. I mean, I was not a follower by no means, but I watched many of his programs, said, oh, okay, that's interesting, look at that. And that was it. I never went beyond that. Of course, now when I look back, you know, and do a little bit of revisionism, review, I find that Mr. Wizard, name is Don Herbert, okay? And Don Herbert, Mr. Wizard, he never explained anything. He was like good old Mary Poppins the other day. Let me put her up here again. See if we can, give me a second here.
Will you be good enough to explain all this?
First of all, I would like to make one thing quite clear.
Yes?
I never explain anything.
Okay, so we have Mary Poppins saying she doesn't explain anything. Of course, she's a witch.
Yes.
And these guys are more or less the same thing. They're witch doctors. You know, they dance around the fire and they do miracles, but they never explain anything. They just describe, they point and say, look at the magic I did in front of you. You know, they go to visit the pygmies in the middle of Africa, and they take a magnet and they say, see, I do magic. I can pull iron filings from the floor
Will you be good enough to explain
without
all this?
anything between.
First of all, I would like to make one thing quite clear.
And the pygmy says, you know, okay, pale face,
I never
tell me
explained
how it happened. Tell me the mechanism. And the guy has to shut up because he doesn't know the mechanism.
First of all, I would like to
So,
make
you know,
one thing
doing some
quite
magic
clear.
tricks
Yes.
in front of the screen there for the kids, especially because this was a kids program primarily. You haven't explained anything. These guys never explain
Will
anything.
you be good enough to
Okay.
explain all this?
Here's one case, you know, again, he doesn't explain anything. He just did these flashy experiments. And I got a couple examples here. Here's one. He sprinkles some iron filings around
First of all, I would like to make
a
one
coil
thing
there,
quite clear.
live coil. Then he has this rod being pushed in between there, okay? And taps the board, and you can see they align, okay? So he's showing the strength of the magnetic field and how it increased by putting the iron bar in there, okay?
I never explained
And, you know, did he explain it? No, he didn't explain it. He just showed a flashy thing. And this has become the norm
I would like to make one thing quite clear.
Yes.
in television, so-called science
I
today.
never explained
Okay,
anything.
it's become the blueprint for how they do things, and you know they don't explain anything. In fact, a lot of people have lost
First of all, I would like to make one thing
their
quite
interest in
clear.
physics and science because they've seen a lot of these experiments over and over again. We had him for, if he was in the 50s, we're what, in 2020 now? That's 70 years. 70 years of the same thing. So he who watched, you know, magnets, gravity, etc., he's familiar with the effects. He's never received an explanation. He goes to Quora, asks for an explanation. He gets a mathematical gibberish, some equation there, and says, well, if you want to understand it, you got to go to college, take math courses. And everybody's dumber than, as dumb as they came in. You know, and the only thing people deal with today are other issues like, you know, diversity and Black Lives Matter and, you know, sex of different kinds. We're going to talk a little bit about today because that's what Bill Nye does. And here's a,
Yes.
let me, give me a second here.
Anything.
Here's
Will you be good enough to explain
something that people would be talking about these days instead. You know, instead of watching the program, seeing what he does, they would be watching the Wiz's hands. You know, they're all around Dorothy, okay? They would be talking about, you know, his liberties he's taking with Dorothy there.
First of all, I would
I'm
like
sure
to make
that's
one
the
thing
way
quite clear.
the blogs would be discussing his science program. You know, these were different days. I remember. You know, people had no problem with all this stuff in the old days, but today it's a major problem. You know, put your hand around the girl. Ooh, did she give you consent? Did she consent? Okay. Here's one example. He pours, because he's doing the same thing these days, not these days, but in the 80s. 30 years later, he was doing the same thing. A little older now, but what does he do? Well, he shows a description. Okay, he says, look, I'm going to pour some iron filings over this kid's hand. And he says, you know, this shows that there is a magnet underneath the paper. Because see, they align around his hand and over his hand. It's 3D, and so this field, whatever this field is, it's 3D, and it just goes right through his hand. Great. I mean, the description is great. Now tell me how Mother Nature does this magic trick, and that's where this guy never comes in. You know, none of these people come in. Okay, and here's another version. Let's see if I can put this up here. Okay, it shows that this kid has a hard time getting a hammer from a very, very strong magnet. Okay, so he's showing the strength of the magnet. He's not telling us what magnetism is or how magnetism works. Okay, so just to show things on TV, flashy things like, oh, this is interesting, well, I wouldn't have a problem with that. But if it's followed up with some kind of explanation of the mechanism, and that's what we're lacking these days. We have no explanation of the mechanisms. And everyone out there today that represents colleges and and schools and does things for kids and so on. They're all doing the same thing. They're all doing descriptions. None of them does explanations. And Bill Nye, as you're going to see in a minute, he's no exception to that rule. That's why I'm bringing this guy up because this fellow, what's his name again? I can't even remember his name. Don, if I can find him here, Don Herbert. Don Herbert is the guy who Bill Nye followed. In fact, he mentions it a couple times because essentially he imitated his program but made it a lot more flashy, more modern. That's about it. So Bill Nye does the same thing as this guy, Don Herbert. Okay, here's Don Herbert on light again. Do we have an explanation? No, all we have is this guy saying, look, white light has many colors. But on the other hand, monochromatic light, you know, lasers, they have a single color and they look like a wave. So he shows a wave. Okay, so what is that wave? I mean, is this what he's referring to?
Yes.
Is that what a wave is to this fellow? And yeah, I have a problem because, again, first they're using waves and they're perpetuating this notion of wave that essentially James Maxwell came up with. You know, he put it all together. It comes even before that with Augustin Fresnel. And what Fresnel did was he discovered the transverse wave, but he didn't have really a very good picture of that. And that comes later, going through Faraday and eventually to Maxwell, where he comes his famous 4 equations. And that's where he comes up with the transverse wave, the pictorial transverse wave. And what is that wave? Let's look at it again, okay? What are you staring at? You're staring at those arrows. Those are not engine arrows. Those are vectors, magnitude and direction. So they created a physical entity, apparently, that you can watch. You know, you're staring at something, you say, well, I see a shape there of some kind that's moving. Yeah, but what you're staring at is mathematical concepts. Those arrows are magnitude and direction. They call them vectors, but that's what it is, just magnitude and direction moving through time. That's mathematical gibberish. It's not a physical object that you're staring at. And just everyone, especially, you know, wave theorists, they treat this as a physical object.
Yes.
And it's not. First of all, it's moving, which automatically disqualifies it as a physical object. And second, what you're seeing are vectors, magnitude and direction, replaced with an arrow, pictorially represented with an arrow, and then they have this arrow moving. So when you look at what they're putting up there, you're saying it's all nonsense, it's idiocy. Because they're kind of fooling your eyes by putting something in there. I mean, if you don't have a pictorial object, then don't put it on the screen. Just say, look, it's magnitude and direction, it's moving. Why do they try to pictorially represent a transverse wave? Because they want to insinuate to you or convince you or persuade you that they're doing physics, that this mathematical gibberish that they have there really is a representation, can be represented through this thingy called a wave. It can be represented into physics. In other words, their mathematical equations describe the invisible world, and this invisible world is of waves. And what are waves? Just magnitude and direction, vectors. So this is the problem. You're looking at an abstraction that has no reality in physics. You got to tell me what physical object Mother Nature uses as a wave. And we're saying it's a rope. A rope is not a wave. Okay? And it's not a two-dimensional, two transverse, you know, two-dimensional waves. What it is a torsion of a rope, of DNA. That's what light is. You can now, at least you have an object. And that's what Mother Nature hopefully does her things with, an object. Why can't you see it? Why can't you touch it? Again, because an object is not that which you can see or touch. An object is that which has shape. You got to put a shape on that screen or point to it or whatever. Okay, bring it to the conference. Okay, this fellow also, it turns out that he goes in there and he shows that light retraces its path. So he shows this. This is in fast motion, by the way. Okay, and comes back right through there. So he's showing how this how light retraces its path through the
Good
mirrors.
enough to explain all this.
And he doesn't explain any of this, of course. He just says it does so. And again, that's another problem, that we have only descriptions. But what is the issue? The issue is that this is a well-known phenomenon of optics. It's known as ray reversibility, or the principle of ray reversibility, or the principle of the reversibility of light, or the path of light. Okay, that means that light, anywhere it goes, listen carefully here, okay? Light, wherever it goes, it retraces its exact path. That sounds like a rope. You know, it twirls. My little rope here. Here we have it, okay? Here's the rope, okay? And it's twirling, right? And my eye is connected to your eye, okay? Let's see if, let's see it here, like that. And it's torquing, okay? It's going to be torquing, right? So you receive the signal at the same time I receive it. Why? Because this is a tautly drawn rope, okay? So it's tight, okay? And so we both received a signal simultaneously along the same path. Now you can understand ray reversibility. Why light retraces its path, because it goes nowhere. There is no little particle traveling or wave traveling two ways. And one way we show this is here. So let me show that ray reversibility first, the concept, the notion, this phenomenon, which dates all the way to the Arabs, okay? 10th century they figured out ray reversibility. And what it is, that light retraces its exact path when it goes through mirrors, bounces off another mirror, comes back. It goes exactly through the same path. And you say, how can that be with particles? If the Earth is moving, you know, the particles should not come back to the source. And yet it does. No matter what we move, it doesn't matter. You say, well, the distance is too short to be able to tell, because if I put a mirror here and the other one across the room, I'll never be able to verify this, right? Well, fortunately, we have a cosmic phenomenon, which experiment, which might help you decide otherwise, okay? And that's that we put a retroreflector on the moon, okay? And here it is. Of course, flat earthers need not apply, okay? But if the Earth is sending little particles, and it's a round trip, 2.4 light seconds, that means it takes 2.5 seconds for light to go to that retroreflector and back to the Earth. While the Earth and the moon both moved, the moon moves 1 kilometer per second around the Earth. That's the speed of the moon around the Earth. So it's moving, and here it turns out that the people in Houston, they send a laser to where that little retroreflector is on the moon, which was placed there by the astronauts. I think it was Apollo 14 or 15. And they get a reflection. But they get an instant reflection. In other words, this is the issue. The issue is that here you see, I've illustrated in one of my videos, but here I put it again, okay? You would have to point, I mean, if the moon is going to be in 1 second somewhere else, you got to point to where the moon is going to be in 1 second. That's not what they do. See, they point directly at the moon and get a reflection no matter where the moon is. They just follow the moon. And you say, how can that be if the photon has to travel 2.5 seconds from Earth to moon and back to the Earth? And the way they explain this is they say, well, you know, the laser from here on Earth, right, shoots gazillions of photons. And you have all this warp space there, right? There's all this warp space in between. And so, you know, they follow the path of warp space. So this guy goes this way, that other guy goes that way. But out of a gazillion photons, one comes back to the observer. That's their explanation, the people in NASA. I mean, these people are idiots, period. They're idiots. That's how they should be treated, okay? Because no way. What they're just saying is inventing, saying, well, yeah, space is warped, so these photons go in every direction, but one of them comes back, and that's what we see. And again, they don't point to where the moon is going to be in 1 second, because that's the way they should do. You know, they should not point the laser directly at the retroreflector. They should point 1 second away, 1.2 seconds away, right? Because that's where the retroreflector is going to be when the laser photon, right, is going to arrive there. So you don't point to the retroreflector, you would point a little over, right? That's not what they do. They point directly at the retroreflector. But they never figure these things out. They're not smart enough. Okay, and here's the rope version. Okay, it doesn't matter where the moon goes, because every atom of the moon is attached to every atom on Earth. That means the atoms on the face of the retroreflector, on that mirror they've got on the moon, it's already tied to the atom in the telescope or the laser or whatever they're using for detection. They're already bound. Okay, the atoms are all bound. So the moon can move anywhere it wants. It doesn't matter. You know, light will always find it. Okay.
First of all, I would like to make one thing quite
clear. They never figure these things out. And again, you have to assume again that every atom is interconnected. That not only explains light, but it explains gravity as well. Okay. Okay. So who?
Yes.
I know. Here I have some more. So next topic that this fellow talks about is gravity. You know. So here we had magnetism, light. Now we have gravity. And here he shows a kid how gravity more or less works. And the interesting here is that he doesn't learn his own lesson. That you need a connector, a physical connector, in this case some kind of string or rope, right, to be able to produce this effect. I want to see him try without any physical object as a mediator. I want him to take that rope away. I want to see if he can do the same trick without that rope. And he doesn't learn his own lesson that you need a physical mediator, okay, to do gravity, and he doesn't learn that. Okay, so what does he do? Well, he takes the kid out into the field, okay?
Yes.
And he's going to swing this thing around, and he's going to ask the kid to cut the bottom part. Now the top part flies off. Again, showing that, you know, you can't do Earth going around the sun unless you have a connector. And if you were to cut the ropes, I think it flies out instantaneously, and not like Brian Greene told us a couple weeks ago that it would take 8 minutes for that ball to fly out of there, because that's how nothing can travel faster than light. Okay, I'm sure that they would be surprised if they had God's eyes and found that every atom on Earth is connected to every atom in the sun. So the sun twirls the Earth around itself by the gazillions of ropes that are interconnecting their mutual atoms. If we could, we can't, but if we could cut those ropes, right, the Earth would fly away instantaneously. Just like a guy hanging from a mountain in here, if you cut that rope, that guy falls instantaneously. It doesn't take a couple of microseconds for the information to reach him. The way mathematical physics does their thing. Okay, so what did this whiz do, this wizard, okay? Well, he does a lot of descriptions. For example, here he takes a girl and he measures, or he determines her center of gravity and just clarifies that it's behind, you know, in the middle of her body, behind her belly button somewhere, okay? So that's a description. Does he explain anything with this? No, he doesn't explain why that's the case, okay? Here's a little experiment that good old The Wiz did, which we used to do. I used to go to the Boys Club in Rockford, Illinois, and we made this. We had a shop there. It was a great boys club, and we made this little thing, and it was so much fun because you would put it in your finger, it would fall off. Okay, but when you put a belt on it, just like he's showing here, in a minute here. If you put a belt on it, it holds. It just holds onto it. Oh, I didn't get the part of the belt.
To explain all this.
Okay. Well, anyways, if you put a belt, it just it doesn't fall. I forgot to include that part in the film. Sorry about that. Anyways, you would hold it, and this it was a genie, it's shaped like a genie. You put a belt, you could hold it, but if you take the belt out, the genie would fall. And so again, that shows something about the center of mass, something about gravity, but this fellow doesn't explain that. He just says it is so. Look at the magic trick. It's all these people are magicians. They do their magic trick, but they don't explain how he did the trick. So that's what science has become. And why don't they explain it? Because they don't know how it's done. See, they're not the magicians. The magician is Mother Nature. They just show. They're just master of ceremonies. They point to the Mother Nature, say, look what Mother Nature does. And Mother Nature does her magic trick and see, oh, wasn't that awesome? Yeah, could you explain how Mother Nature did the trick?
Yes.
And that's where, no, I can describe it. And they describe it, they put math there, they describe it with equations, and they call that science. So yeah, I do criticize science and all these so-called scientists and all these so-called celebrities that are making money just doing descriptions and calling science a bunch of descriptions, mathematical descriptions. Okay, and just a final one here. Here we have a little trick, another magic trick that the Wiz does. And what he does is he rolls up a couple funnels there up a hill. And you say, how does that work? And it turns out that the trick is here. See, it rolls up the hill. But see, that's an optical illusion. What really happens is that the boards, the two rails, they're open, and so the funnel is actually falling, going lower. As you can see the marks there, the kid is going to measure the funnel at starting point here, and right in the center he puts the mark. And now when it rolls, as soon as he puts the mark, you can see it's above the funnel. So it's a optical illusion. It looks like it's going up when it's actually, the funnel is actually going lower. The center of gravity is going lower. Okay. And so these are magic tricks. They like to dazzle the crowds. You know, they go to the pygmies with the magnet and say, look, I can pick up iron filings. Look, I let go of the stick and it falls to the floor. You didn't know that, did you? No, they didn't. So explain the magic trick now. And again, they're master of ceremony. They just present Mother Nature, what she does, and they don't explain anything. They are not the magicians who explain how the trick is done. They're not the guys who actually, you know, how the trick is done, and they are the magicians who perform the trick, because they would not be able to do that, not with their explanations. They got ridiculous explanation. Okay, so here we go to Bill Nye, and Bill Nye, he's a mechanical engineer, television presenter, and another one of those science communicators. What was a science communicator? Was one of those popularizers of so-called science, quotation on that, okay? He's a host of a science show called Bill Nye the Science Guy, past tense now, and he hosts he hosted a Netflix show, called Bill Nye Saves the World. And I don't know if he can save himself, you know, but the way I look at this fella, if I can put this thing up here, is more like a clown, okay? I think he does clowning around, a lot of clowning around. Now, there's nothing wrong. I have nothing wrong with clowning around and, you know, horsing around. No problem with that. I hate it when these people present that in the guise of science, saying what they're doing is science. That's where I have a problem with these people, and that's why I treat them with the respect that they deserve. And so, no, I don't insult them. I don't belittle them. I treat them with the respect that they deserve. And again, the problem here is that these guys, I have no problem with clowning around, but don't tell me that you're doing science. You'll do science when you explain. And Bill Nye does not explain anything, just like Mary Poppins, okay? Okay, so he started off being the so-called science guy. And see if I can get it rolling here. There he goes. And this is how he started.
A mixture of all the colors of the rainbow. Red light can make you stop. Green light can make you go. The other colors can make you disco.
Let me see if I can silence one of these here. Let me see if I can find her.
Light is a mixture of all the
I think I
colors
got
of the
Mary
rainbow.
Poppins there, don't I?
Red
I don't know if you were hearing Mary Poppins all this time, but let me get her out of here because I see that her sound is moving. So please let me know. Yeah, okay, so let me see if I can get her out. Where is she? Here she is.
Did you know that white light is a mixture of all the colors of the rainbow? Red light can make you stop.
Okay, again, he started being the science guy. Okay. And let's remove this guy as well. He started doing the science guy, and then he moved on to bigger and better things. Bill Nye did. And so one of the things we have to look at is what the career path of all these so-called celebrities was, okay, and is to this day, okay. So here, let me get you another one of these. And this is from Bill Nye again. This is, if I can get him to, give me a second here. Takes a second to get these things rolling. Sometimes they're very hard to manage when one person does it alone, okay? Okay, here he goes, and he blows hot air. This is what he does these days, or did lightly, does a little bit of alchemy, okay? Greases hands, okay? And feet as well. I guess they all have to be greased. He laughs a lot about it, you know, laughs all the way to the bank, okay? So, yeah, this is what these people do. They do this for a living, okay? And they think they're doing science, and all they're doing is just making money. They're making programs, the documentaries, and all these people call them up to serve on their programs. Why? Because they're popular. They're faces that people recognize, and people really watch these people, follow these people only because of the entertainment. There is no science there other than the description, other than wowing the crowds, like, wow, oh man, that's awesome. That's it. There's never an explanation following that. And, you know, he's this Bill Nye is in the same tradition. Okay, here's what Bill Nye does these days. Let's see if we can get him up here. What he tackles sex, global warming, GMOs, technology, alternative medicine. This is what he's into. This is what he's moved on to. Again, he's a mechanical engineer, okay? So this is what the topics that he raised, at least in his last program. I think it ran all the way to 2018. Probably was going to be renewed, I don't know. And so this is what they do. What does this have to do with physics or even with mechanical engineering, which is apparently what he studied? And it's got very little, in fact. It's got a lot to do with what people are into these days, which is food, health, you know, whether we should have sex with the same sex, technology, like we're going out into space. You know, a lot of this stuff has nothing to do with science, with explaining a mechanism. And so again, there's a lot of confusion between what technology is and what science is, okay? And here's, and give me a second here to get these things rolling, okay? One of the things he does these days, he sells diversity, okay? And here you can see what he's talking about, okay? You would think that he's just selling, you know, diversity. That's all he's doing. He's selling homosexuality. He's saying it's okay. Why? Because this is what people are saying out there. He knows, in other words, they do market studies and they say, okay, this is what people think out there. At least 50% of the people, they're okay with all this. And so this is what he sells. He says, look, it's scientifically correct. There's no problem with this. You know, aside from the fact that that's his personal opinion, what does it have to do with science? You know, I mean, these are opinions. You know, some people have no problem with homosexual sex. Other people do. So are you going to say that the people who have a problem with it are unscientific? Is that what we're saying here? So we got a problem because they're introducing political things in the guise of science. And I have a little bit of problem with that, okay? And again, it has nothing to do with my personal opinion on these issues. It has to do with the fact that they're introducing these subjects as scientific first, and second, they're just giving you their opinion to shove down your throat their religion. That's all they're doing. They're giving you their opinion, saying, oh, it's scientific. Mine is a scientific opinion. That's what Bill Nye is saying, okay? Here's another one that he deals with, okay? And let's see if I can get it rolling here. Got to be careful the sound doesn't stay. Okay, so here it goes. And this one has to do with climate change.
We hear it so much that it feels like a buzzword, but it is far from it. Climate change is a real and serious issue. We hear it so much that it feels like a buzzword, but it is far from it. Climate change is a real and serious issue.
Is that science? Bill Nye is saying that climate change and that we should do this and should do that. I mean, the shoulds are all opinions, politics, religion. That's got nothing to do with science. In science, we want to have objective mechanisms. Just tell me how something works, and then we're done with science. But these people are using the word science in all their programs, right? They overuse that, and what are they saying? They're saying, oh, climate change, it's happening, we got to do something about it. And if you don't agree with them, you're unscientific. That's where I have a problem. I have no problem with someone saying or arguing, look, I think climate change is occurring, I think it's bad. Okay, that's their argument, no problem there. That's different than saying, my argument is scientific, yours is not, Bill, because you may not agree with me. That's a totally different thing. And presenting it in the guise of science, it just adds, to the problem. Adds insult to injury. Okay, this is where I see the danger of all these people, all these celebrities. They're putting their face behind their opinions, and people just believe the opinion because they think, oh, it's scientific because Bill Nye said it. Okay, and let's see, here we have another one. And this one has to do with the modified. Genetically modified foods.
The good side is we get more
organisms.
Yield per hectare or acre.
Okay, one.
So in other words, we have less impactful farming. In other words, we affect the ecosystem less because we'll produce more food on less land. That's the upside of genetically modified.
That's 1-4.
We're using biology to fight pests and diseases rather than chemistry. The unintended consequence, the classic one, is one that everybody has observed, is the monarch butterflies, where we have reduced their population 90%, not as a consequence exactly of raising genetically modified food, but by using this extraordinarily effective herbicide that has killed the milk flowers or milkweeds, which...
Okay, now, does that have anything to do with science? Talking about technology, genetically modified organisms or foods? Is this science? Is this what we call science? Or is this technology? Is science the same thing as technology? So this is another issue, because people say, oh, science. And they always say science and technology, meaning these two words are not synonyms, but people don't realize that because every time they introduce technology, they say, oh, it's science. The scientist just told us. No, that's not science. Technology is not science. Developing gadgets, or in this case, genetically modified foods or whatever, that's not science. And instead, it'd be nice if you use that time to explain things. Like, for example, what I showed, I think a couple weeks ago, which is this. Here we're having fruits and veggies come out with Siamese twins. And I have an explanation for this. I'm saying this has to do with the fact that we've been artificially growing these things, doing artificial selection for many, many years. And as a result, today, all these fruits and veggies, a lot of them are losing their genetic diversity. And after a while, they start having big problems. These are genetic problems. And people say, they just say, how interesting. Well, this is what it would be nice if Bill Nye would explain. Look, we have these Siamese twins, watermelons and tomatoes and potatoes and whatever. Can you explain why we have a problem? No, they just said, genetically modified foods. It's good and it's bad. We have two opinions on that, right? Both sides, just in case, to cover all the bases. Okay, here's another one. And again, let me turn this one on.
Welcome to the show. I'm Bill Nye, and I'm here to save the world. It's an alternative medical treatment, meaning it's an alternative to actual medicine. I don't make the rules, people. This is science.
So, was that science? Or was he just giving his opinion? See, again, we have all these issues that people like him, celebrities, are putting their face behind, just saying, "Oh, I'm a scientist, and if you don't agree with me, right, with my opinion, you're unscientific because I represent the scientific establishment, and we have proven this." That's the message that gets across. And so a lot of people form their opinions based on this, and of course they have these political opinions as a result as well, right? So keep that in mind. And here, let me give you the last one. See if it works. Oh, it's the same one. Sorry. I had that one as a backup in case the sound didn't work. Okay, anyways, so what is the homework? What is the summary from all this debate about Bill Nye? Well, this is what I have. I have a few questions that you can take as homework, and please feel free to answer them. You know, I'll address good questions or good answers that people give. Okay, and here is homework questions to work on. Is what Bill Nye does science? Is that what we call science? What is your definition of science? And if so, does Bill Nye, what he does, fit the bill? Is he a science communicator? Is he a popularizer of science or of his opinions of fads? You know, right now we have a lot of fads, diversity, we have Black Lives Matter. I'm sure he's going to talk a little bit about that as well. White Lives Matter as well. They created all these movements out there. Is he a science communicator, or is he just giving his opinions? Political, religious, whatever. Is he just being is he just being a politically correct salesman? Is he just a salesman, a preacher? He's trying to be politically correct because all these fads are very popular these days, and so, you know, health foods, doing exercise, a lot of people are into all that stuff. And so that's what he talks about because they do market studies and say, well, this is what people want to hear. And he said, yeah, here we have a science guy, you know, and he's going to tell you about all these things, about genetically modified foods, about doing exercise, about diversity, and you should have sex with anyone you want because it's okay and science says so. And so is this science, or is he just selling you his opinions, his political opinions? And then the question is, the big one there is technology the same thing as science? Is there a difference between science and technology, or are they the same thing? Are they synonyms? Why do we have two words if they're synonyms? And if they're not, what is your definition of technology? What is your definition of science? Is what Bill Nye does science? Is he the science guy or the tech guy? Okay, I call him the psyops guy, not the science guy, because I think he does more recruiting for the official versions than real science. And does he just regurgitate quantum mechanics and general relativity catechism? Not directly, because he doesn't talk specifically about those subjects all the time, or rarely, in fact. But they're in the background. He brings them up like casually and says, well, you know, like QM just proved that. General relativity proved that, you know. So if he's going to talk about space, going into space and so on, he's going to bring general relativity and therefore reinforce the official catechism. And so this is the issue. The issue is that whether this guy is doing science. And so, yeah, please let me know. Put some good comments on that, and we'll find out what you have to say about it. I don't think he's a scientist.